One planet in our solar system does not spin, it rolls. Uranus is the seventh planet from the Sun and remains one of the most enigmatic subjects in planetary science. While the other major planets rotate more or less upright relative to their orbital paths, Uranus is tilted at a nearly 98-degree angle. This orientation makes it a unique outlier in our celestial neighborhood. Scientists prioritize the study of Uranus because its physical state suggests a violent and chaotic history that challenges standard models of planetary formation. Understanding why this planet sits on its side provides critical data regarding the early development of the solar system. Furthermore, as we discover thousands of planets orbiting other stars, many appear to be ice giants, similar to Uranus. Solving the mysteries of this local world allows researchers to better interpret the nature of distant solar systems across the galaxy. The current state of Uranus is likely the result of a specific sequence of cosmic events. Every planet begins its life as a spinning collection of gas and dust. In a typical scenario, gravity pulls this material together into a sphere that rotates in alignment with the rest of the solar system. The anomaly of Uranus began with a massive disruption. Scientific evidence suggests that billions of years ago, a young Uranus was struck by an object approximately twice the size of Earth. In the vacuum of space where there is no friction to arrest movement, the force of such an impact can permanently alter a planet's trajectory. The collision was powerful enough to knock the planet over. Rather than shattering or being pushed out of its orbit, Uranus absorbed the energy of the impact and tipped onto its side. Because a planet's moons and rings form from the debris disks surrounding it, these features also shifted. Consequently, the entire Uranian system, its 13 rings and 28 moons, became tilted along with the planet. This physical shift created a series of extreme environmental consequences. Because Uranus is tilted so far, its poles face the Sun directly at different points in its orbit. One pole receives 42 years of continuous sunlight, while the other is shrouded in 42 years of total darkness. This seasonal extreme dictates the planet's atmospheric behavior. Despite being an ice giant composed of water, methane, and ammonia, Uranus does not behave like a frozen static ball. The massive imbalance of solar heating drives winds that can reach speeds of 500 miles per hour. These winds circulate through an atmosphere that is the coldest in the solar system, with temperatures dropping to minus 370 degrees Fahrenheit. Our understanding of Uranus is defined by strict scientific boundaries. We know for certain that the planet is an ice giant, which distinguishes it from the gas giants Jupiter and Saturn. While Jupiter and Saturn are mostly hydrogen and helium, Uranus contains a much higher proportion of ices, the chemical term for heavier elements like oxygen, carbon, and nitrogen. We also know that the planet's magnetic field is as unusual as its tilt. On Earth, the magnetic field is roughly aligned with the north and south poles. On Uranus, the magnetic field is tilted 60 degrees away from the axis of rotation and is offset from the planet's center. This creates a wobbly, irregular magnetosphere that interacts with the solar wind in ways seen nowhere else in the solar system. There are aspects of Uranus that remain theoretical. One prominent hypothesis involves the internal pressure of the planet. Scientists suggest that deep within the atmosphere, the pressure is so intense that it could break down methane molecules, squeezing the carbon into crystals. This would theoretically result in diamond rain falling toward the planetary core. While laboratory experiments on Earth have replicated these conditions, we lack the direct observational data from the planet itself to confirm it. The origin of the tilt also remains a subject of ongoing debate. While a single massive impact is the leading theory, some researchers propose that a series of smaller collisions, or even the gravitational pull of a large, long-lost moon, could have gradually tipped the planet. Until a dedicated mission returns to Uranus to study its interior structure, these remain sophisticated possibilities rather than proven facts. It is important to debunk the myth that Uranus is a featureless, inactive world. When the Voyager 2 spacecraft flew past the planet in 1986, it appeared as a smooth, pale blue sphere. This led to a common misconception that the planet was geologically and atmospherically dead. However, more recent observations from the Hubble Space Telescope and the James Webb Space Telescope have revealed bright clouds, shifting bands, and dynamic storm systems. The planet is not featureless. It was simply being observed during a quiet period of its 84-year orbit. Another common misconception is that Uranus is made of solid ice. In the context of planetary science, ice refers to the chemical compounds, not necessarily their physical state. Deep inside the planet, these materials are likely under such high pressure that they exist as a hot, dense, superionic liquid, a state of matter that acts like both a solid and a liquid simultaneously. From a human scale perspective, Uranus represents the vast scale and unpredictability of the universe. It is a world where the sun is merely a distant bright point in the sky, providing little warmth but dictating a seasonal cycle that lasts a human lifetime. It is a place where up and down are relative terms, and where the very orientation of the planet serves as a fossilized record of a billion-year-old catastrophe. The sideways rotation of Uranus is a calm reminder of the violent history that shaped our stable home. It sits in the outer reaches of the solar system as a survivor of the chaotic era of planetary formation. By studying this misfit planet, we are not just looking at a distant ball of ice. We are looking at the scars of a cosmic collision that occurred before the first life emerged on Earth. Uranus remains a silent sentinel of the deep solar system. It rolls through the dark, its rings spinning vertically like a giant wheel, holding the secrets of the forces that can knock a world off its feet. It is a reminder that in the vastness of space, the unusual is often the key to understanding the fundamental laws that govern us all. The mystery of the sideways planet is not a puzzle to be solved with a joke, but a window into the raw, transformative power of the cosmos.